Liquids and gases are flowing substances and are commonly called fluids. Let us find out if fluids also exert pressure and if the pressure exerted by them also depends on the area on which the force acts. To find the answer, we shall perform an interesting activity. Fix a cylindrical glass tube about 1 centimeter long near the bottom of a plastic bottle. This can be done by slightly heating one end of the glass tube and then quickly inserting it near the bottom of the bottle. Seal it with molten wax to ensure that the water does not leak from the joint. Fit a rubber balloon over the mouth of the glass tube. Half fill the bottle with water. Note that as water is poured into the bottle, the balloon fixed to the glass tube begins to bulge out gradually. You will observe that the bulge in the rubber balloon increases as more water is poured. The balloon bulges out because the water column in the bottle exerts pressure on the walls of the container. Now, you will observe that as more water is poured into the bottle, the level of water rises. As a result, the force exerted by the column of water increases, and so does the pressure. It is important to note that the area on which the weight of water acts remains the same. We often see fountains of water coming out of the leaking joints or holes in pipes supplying water. It is due to the pressure exerted by water on the walls of the pipes. We can, therefore, conclude that fluids exert pressure which depends on the magnitude of force and the area of cross-section on which the force acts. Properties of fluids. Fluids enclosed in a container exerts equal pressure in all directions. When we blow air into a balloon, it gets inflated. As we keep blowing air into the balloon, it bursts after a certain size is reached. This happens because the air in the balloon exerts pressure on the walls of the balloon. When this pressure becomes large enough, the balloon bursts. You might have seen different shapes of balloons at the balloon vendor's shop. When a balloon is filled with air, it acquires its characteristic shape, round or oval. Similarly, when air is filled in a bicycle tube, it retains its shape. This is because air exerts pressure in all directions, and this helps the objects to maintain their original uniform shape. Fluids flow from a region of higher pressure to a lower pressure. Now, let us understand an important property of fluids. For this, we need to perform an activity. Activity: take 2 plastic bottles marked A and B such that they are joined near the base by means of a rubber tube, which can be closed with a clamp. Keeping the tube closed with a clamp, fill bottle A completely with water and bottle B just a little above the rubber tube. Note the level of water into the 2 bottles. You will observe that when the clamp is set loose, water flows from bottle A into bottle B till the level of water in both the bottles becomes equal. This is due to the fact that water flows from a higher level to a lower level. You may now wonder, how is this related to pressure? Well, we have just learned that if the height of the water column is more, it exerts a greater pressure. That is, higher the level of water, greater is the pressure in that region. Hence, the water flows from a region of higher pressure in bottle A to a region of lower pressure in bottle B. Similarly, when the valve of a LPG gas cylinder is opened, the gas flows out into the pipe because the gas is stored under higher pressure in the cylinder.